In this tutorial, we are going to study the concept of rigid motion on geometrical shapes, and we will also look at the rigid motions from the lens of congruency, that how does congruency is preserved, congruency of shapes is preserved when we apply any one of these rigid motions. And we say that there are three types of rigid motions on geometrical shapes. One is translation, second is rotation, and the third is reflection. Okay, so let's take a look at the translation first. So to explain translation, we have this object, a triangle here, and let's say these are 3 points of this triangle, the vertices A, B, and C, and the coordinates of A are -3 and y is 0. Likewise, coordinates of point B are -1 and 0, and then you have coordinates of C as -1, which is the x value, and y is 2, right? Now we are going to apply a translation on this object. Translation means that this object in its entirety, without modifying its shape and size, is moved certain units to the right or the left, meaning either in the x direction, or you can move it up and down in the y direction, or a combination of both, okay? So in this case, what I'm going to do is I'm going to move 3 units to the right. The new triangle that we obtain as a result of this translation is now triangle DEF, where the coordinates of D are x is 0 and y is 0, right? Likewise, the coordinates of point E are x is 2 and y is 0. And the coordinates of point F are x is 2 and y is 2. So you will notice that when we were applying a translation of 3 units to the right from original position, coordinates of x of each point on this shape are changed, right? And it is only the x coordinate that has changed. But the shape of this triangle is as it was before, right? We have preserved all of its angle as well. We have preserved the dimensional aspect of 3 sides of this triangle, right? So we say that the new triangle DEF is identical to the original triangle that was ABC, because you see that the side DE is identical to side AB, right? The angle at D is identical to angle at vertex A. The dimension EF of this new triangle is identical to the dimension BC. That means the congruency of these two shapes is there. That means the rigid motion of translation helps maintain the congruency of objects. So that is about translation. Okay. Now let's talk about the rotation. To understand rotation, what we have done is we have created an object ABCD. It is a trapezium, right? And the base of this trapezium, which is at AB, is 3 units long, whatever these units are, whether centimeter or inches, right? And the line segment CD, which is parallel to AB, is only 1 unit long, right? And let's say the dimension AD is 2 units long, okay? It may not be precise, but this is just to give you a very general idea, okay? Now we are going to apply a rotation to it with reference to a point which is external to the shape. So when we apply this rotation, let's say this rotation is of -31 degree. That means you are rotating it in the anti-clockwise direction, okay? So let's say this is your object, the object number 2, the trapezium, which is after the rotation, and your original trapezium is right here, the shape number 1. So you observe that as you were applying the rotation of this object with reference to a point which was external to the shape, the side lengths, the dimensions of these sides, they did not change, right? We simply rotated the object from its original location 1 to the new location 2. That's all we did. These angles, the included angles between the side, none of those were changed. Everything was preserved, meaning the relative position of these points that were on the shape with respect to each other, they did not change. So we can conclude that when you apply rotation to any object, any geometrical figure, the size and the shape is preserved. Hence, we say that the two shapes before and after are congruent to each other. Okay, so now let us take a look at reflection. In reflection, the very first thing what we need to do is we need to define a mirror line, a line such that it creates a replica of image. In this case, I am saying that it is my y-axis which is going to act as the mirror line. Now, once you have defined your mirror line, the next step is, of course, to create a shape such that you can see the reflection of that from the mirror line. Okay, so in this case, I am creating this triangle, and as soon as we finished creating this triangle, you observe that you have obtained a replica of that. Okay, so let's say this is my original triangle ABC that has been reflected from this mirror line, okay, and this is the image. The image is triangle D, E, and F. And a unique property of reflection is that if you take any point on the original shape and if you measure the distance of that point from the mirror line, and if you take the distance from the mirror line to the reflected point, which is identical to the original image, you will notice that these two dimensions are equal. So this distance of point C from the mirror line is identical to distance of the point E from the mirror line. And that is exactly what reflection does, okay? In this case, it is very easy to see visually that these two shapes are identical because once again, we are saying that all the angles, all the points of the original shape have been preserved in the reflected shape. So the triangle ABC is congruent to the triangle DEF. Okay. Now we have studied the three cases of translation, rotation, and reflection individually, and we have seen that the congruency of the shapes is maintained when you apply these rigid motions. And next we are going to study that if you apply one or more of these transformations, let's say a combination of translation and rotation, will the congruency of shape be preserved, right? Let's go take a look at that. To study that, what we have done is we have created a triangle ABC, a right angle triangle, and the dimensions of the base AB is 2 units. The dimension of this height BC is also 2 units, and the angle B is 90 degrees, okay, because this is a right angle triangle, correct? Now we are going to apply a series of transformations on this object, okay? So first let's apply a translation of, let's say, few units. Alright, so now let's apply one more transformation. Let's say we are rotating this object 90 degrees in the clockwise direction, okay? So in that case, you will notice that the dimension AB has now become, let's say, the dimension DE in this case, because it has been rotated 90 degrees, okay? And the length of this dimension is still 2 units, right? And likewise, the height, which was BC previously, has converted to the base and it is still 2 units. Okay, and the included angle between these two is still 90 degrees. So if you were to write down, you will say that the dimension AB is identical to the dimension DE, right? Dimension BC of this original triangle is equal to the dimension DF. The angle at B is equal to angle at D. And by the definition of this S, and A criteria, right, we can say that the triangle ABC is congruent to the triangle DE and F. And DEF is a triangle that you obtain after applying two transformations. First, you applied a translation and then you applied a rotation, right? But the shape still has been preserved. That means the principles of congruency are well maintained when you apply one or more of these rigid motions to any geometrical shape, and those motions being the translation, the rotation, and the reflection. With that, we will take a pause here, and it was our objective to show that how rigid motions will maintain the congruency of shapes.